Hi, welcome to part 3 of the 6-part series looking at how to create a maze game using Pygame. In this part we are going to improve the UI by adding in a title bar and start importing the levels by iterating through a folder that contains the 46 images in the tile set that make up the various mazes, and we're going to then read the CSV file that says where each of those tiles go in particular mazes, and then we're going to make sure that that level displays behind the player's character. Beginning on the main.py file, we are going to import in a font that we are going to use as part of our UI. And this font is in the assets folder. And we're going to set a variable called font equal to pygame.font.font. And then reference where that font is stored. And it's in the assets/fonts/Atari classic.ttf. And we're going to want it to display at 20 pixels. We're going to write a method to draw the text on the screen. So we're going to define a method called drawText that takes in the text, the font, the color we want it, and where we want it, so the X and Y coordinates on the screen. And this is going to create an image where it has rendered the font, and it takes the text, converts it into a string, then has true, and then the color of the text. We're then going to blit this image onto the screen at the X and Y coordinates. We're now going to create a top bar. So this is the info bar that will display at the top of every screen when we are playing a level. We're going to call this draw top bar. In this method, we're going to draw a rectangle at the top of the screen. The rectangle is going to be a color called c.bar, which is a color that we will be storing in our constants file. And then we are saying where on the screen we want to display this. And we want to display it starting from position 0, 0, which is the top left corner of the screen. And we want it to be as wide as the screen and as tall as we are defining our top bar to be, which will be a constant we will set in our constants file. We are then going to draw a line under this rectangle as wide as the screen, and it will be 2 pixels thick. We are then going to draw some text using that helper method that we've just written. And inside this, we're going to have the text maze game. It will be displayed in the Atari Classic font. It'll be in a text color called text that's coming from our constants file. And it will be positioned with X being half the screen width minus 75 and half the top bar minus 10. So this should position it roughly in the center of the screen. Going to our constants, we need to add in these values that we have referenced. So we need to enter in bar, line, and text, and also the top bar value. We are setting bar to be 51, 51, 102. Line to be 51, 153, 204, text to be 153, 204, 170, and top bar was set to be 50. Moving back to main, we're going down to the game loop and we are telling the program to draw our top bar. Now, currently the character can run through it because there's nothing to say where the character should move and how to move between levels. So that's what we're going to do now. We're going to input in some background tiles. And part of this will mean that when we create the level, we will be also creating the player character in a particular position. So we are commenting out the player that we created previously, and we are going to create some functions to create the maze and a function to set up the maze. and an area to store the tile map. Now, the tile map, we are going to store it in an array called tile list, which initially is going to be empty. And then for every item in the range, which is the number of tiles in our tile set, so we're using a constant called tile type, which will be set to 46 because there's 46 different tiles numbered from 0 to 45. And we're going to make a temporary variable called tile image, which is going to store pygame.image.load. And this is going to load the image from the assets/images/tiles, and then it's going to use the string format, which will take the value of X and put that into the string. And then we're going to convert that to alpha. We're then going to scale that image using pygame.transform.scale, and we're going to feed in that tile image that we've just created, and we're going to resize it to the width of our tile size and the height of our tile size, so we get square tiles. And we're going to use a constant here called tile size. We're then going to append tile image to the tile list. So at the end of this for loop, that tile list will have 46 images stored in it. Moving back to our constants, we are going to now put in information about the tiles. So the tile size is 32 times by the amount we are scaling. So I'm going to put in a new constant called scale, and this is how much we are scaling the entire game by. So to begin with, we're only going to have it as its standard size, so scale be 1, and then I'm going to p-scale and putting scale times 1.5 in. And then we have tile types, so this is the number of tile types there are, and there are 46 tiles. Returning back to main.py, we are now going to create a method to create the maze. And this is going to take in information about what level you want the maze to be created for. And we are going to create a data frame, initialize it to empty, and then we are going to create a variable called file, which is taking from the levels folder a file called level_, and then the number of the level.csv. And if there are actually no more levels, that file, when you run a .exists method against it, will return as false. Before I continue here, what I want to do is go do some setting up of variables. We are going to set the level that we want to load to 1 and finish to false to say that we have not yet finished the game. We're going to create a variable called finish, which is equal to not the result of an exists check against that file. So if it exists, then finish will be false. And if it does not exist, finish will be true. So if we have not finished, we are going to import in the file. And in order to do that, we need to import in the exists check and also pandas. From os.path, we're importing in exists. And we're going to import pandas in as PD to again save us from some typing. We are going to assign to the data frame that was empty the results of pandas.read CSV and then the file that we've pre-assigned. And we're going to say the header is none because the levels themselves do not contain headers. We're then going to return to the user the data frame and whether the game has been finished or not. Second method for doing these tiles is one called setting up the maze, and this is going to have two variables assigned at the start. It's going to have maze data and finish, and it is going to get this information from the create maze method. So the maze is going to equal the initialized maze from the maze class. And if the game is not finished, we are going to process the data that we have received in order to create the maze itself. So we are going to write a method called process data in the maze class. And this is going to take in the data about the maze, the list of tiles, and the animation of the character. When we initialize the maze, we are going to create a player, and we're going to set the player to be equal to maze.player. And then we are going to return the maze, the player, and whether the game has been finished. So outside these methods, we are going to assign to the values maze, player, and finish the results of that method that we have just written, where we have passed in the level that we are starting with. Going back to our imports, we need to say from maze, we are importing the class maze, and we need to create that. So moving across to the maze.py file, from character, we are going to import the character class because we are going to be using that within this. We're also going to import the constants file, and we're going to call it C to save us from needing to type constants repeatedly. And then we're going to create our maze class. And again, we need to initialize the instances of this class. And in this case, it's going to just take in itself as its input, and it's going to set self.mapTiles equal to an empty array, self.obstacleTiles equal to an empty array, self.exitTile equal to none, self.player equal to none. And then we're going to write the method to process the data, and that will fill in those values that are currently empty or set to none. And this will take in the instance itself, the data that is coming into it, the tile list, and the animation of the characters. So for each Y and row in the data file, so we're going to enumerate this data frame that's coming in, which is where Y is coming from, and row will be the data that is in that row. And we're going to use a method called itertuples, where the index is set to false in order to iterate through the tuples within that data frame. We're then going to take X and tile from the enumerated row. And we're going to set the image equal to the tile list at the index of the tile. And the image rectangle is going to be equal to the image.getRect. So we're going to set a variable called image x, and that is going to be equal to the value coming from the x in this loop multiplied by the size of the tile plus half the tile size. And then we're going to do the same for y. And so image y is equal to y times the size of the tile plus half the tile size. And that is because we're going to use these two values to set the center point of the rectangle. So we need to add half the width of it in order to ensure that the position is centered and not a certain number of pixels offset. For the Y direction, we are also having to consider the size of the top bar, and we want to leave at least the height of the top bar between the topmost tile and the bar itself. So the image rectangle's center is going to be equal to image x, image y. Tile data is going to be an array that consists of image, the image rectangle, the x position, and the y position. We're now going to check to see what type of tile it is. So if it is part of the border or the wall, it will be image number 0. So if the tile is 0, then we are adding this tile to the list of obstacles. So we're doing self.obstacletiles.append, and we're appending the file data to that array. We're now going to see if the tile is an exit tile. And if it is an exit tile, then it will be an image between the numbers 31 and 45. So we're using else if. So else if the tile is greater than or equal to 31 and the tile is less than or equal to 45. We're going to take our self.exit tile and assign the tile data to that variable. So if the tile is where the player is starting from, which means it is an image between 16 and 30, we are using an else if and we're looking to see if the tile is greater than or equal to 16 and also less than or equal to 30. And if it is, we are initializing the player. So the player is equal to a character that is starting at image X, image Y, and the animation being passed to it is Car Annie, which is the animation that was fed in to the creation of this map. We are then setting the player of the instance, so self.player, equal to that player item. The tile data for this tile at position 0 needs to be set to a tile that doesn't have the image of the character on it. And all images without characters are 15 tiles before it in the file. So we are setting the first item in the tile data array to be equal to the item in the tile list 15 below the item that we're currently on. So if the tiles do exist and if they need to be added to the screen and they need to be rendered, we are checking to see if it is greater than or equal to 0. And if it is, we are adding it to the self.maptiles append tile data file. There is something that would be nice to do on this, which is to add some validation in case the array has gone out of bounds, or a try catch to catch if there is a problem with the file that is being imported. As all the levels have been handcrafted, there is a possibility that it will try and read a tile number that is not between 0 and 45. We're now going to write a method called draw. So on this one, we are taking in the parameter of surface. For every tile in the map tiles array, we are going to blit it onto the surface, and we are going to put the image and then which is stored in tile 0, and then the rectangle which is stored in tile 1. Moving back to main.py, we're going back into the game loop and underneath where we have updated the player, and before we draw the player, we are drawing the maze onto the screen. And running this, you can now see that in the background, the maze has appeared. But we can move all over. It doesn't move with us. We do not bang up against the walls. So join us in our next part to make the maze move with the character and allow us to progress between levels so that we can move from level 1 to level 2.